All right, so this one, 3.36. This is use mesh analysis to find IX. So this looks kind of nasty, but it comes out with mesh analysis really nice. So let's do our first bit where we draw our meshes. So this is going to be our mesh I1. This is going to be our mesh I2. And then this one, I3. That's going to be our mesh going around like that. All right, so let's solve this sucker. And we're going to start with I1. We just write I1 down. All the resistors, the total of the resistors touching it. So 0.1 plus 0.5 plus 0.1. Because that's 0.1, 0.5, 0.1. Does anything else touch I1? Well, I2 and I3. So let's do I2 first. Minus I2. I2 touches I3, so now let's look. Which ones touch it? 0.1. That's the only resistor that touches between these two. Cool. So let's look. Any others? Now we're going to start with I3 again, because that one touches up here. I3 times 0.5. Done. And equals, do we have a power supply? Yes, it's 2 volts, and it's going in the same direction, so that's going to be 2. First equation, done. Next, let's start with I2. So we start with I2. The sum of the total touching. So 0.1, 0.5, 0.1. 0.1 plus 0.5 plus 0.1. Does anything touch I2? I1 touches it here at this resistor, and I3 touches it at that resistor. So let's start with the I1 first. I1, and this is 0.1 that touches it. Cool. And then let's do the I3. So I3 also touches I2, touches at the 0.5. Done. And that equals, let's go with this. We have a power supply going in the backwards direction. -3. It's backwards. It's going against the current that we drew. We drew the current here, and this one's going spitting out this way. That's no go. We need a minus in there. That's our second equation. 2/3 of the way down this problem. Let's go. Next one, we got I3. I3. Cool. All the sum of the resistors. That's 0.2, 0.5, 0.5. We can actually start in a thing and go clockwise. So we'll go 0.5, 0.5, 0.2. 0.5 plus 0.5 plus 0.2. Doesn't matter. We got them all? Good. And now, does this touch anything? I3 touches I1 at 0.5 minus I1. And the value that it touches it at is 0.5. Cool. Now we're going to go over here. And I3 touches I2. So I2, and it touches it at 0.5. Cool. And we're up at I3. And we have, this is our direction, and this is spinning out backwards. So this is equal to -4, because it's going in the backwards direction that we're looking at. Sweet. Now let's solve. Let's solve the equation. We have I1, I2, I3, number. I1 equals 0.567, 0.7. I2 equals -0.1. I3 equals -0.5. And our answer to that equals 2. Then there's next one, -0.1. Next one equals 567, 0.7. This one, -0.5. Cool. And that's going to equal to -3. All right. Last one. 7, let's start with the 1. -0.5, -0.5. 2, -0.5. 3.7. And this is going to equal to -4. 7, -1, -5, 2. Good. -1, 7, -5, 3. Good. -7, -5. Yeah, -5. Yeah. -7. Good. -4. Cool. A to the -1, B equals answer. And that's going to equal, we're going to get -8.9, 8.69. We're going to do -14.9, and we're going to get -13.2. And that's going to be I1 equals I2 equals I3. So let's go back to the problem, see what it's asking for. It's asking us to find IX. IX is the one going down between I1 and I2. So I1 is going in the direction of IX is going in the direction of I1. So it's what? IX minus IX that equals I1 minus I2. I1 equals minus 8.69. I2 equals 14.9. So that's going to be what? Equals to 6.25. Done. Boom. That's not that much work for that. This problem looks way more complicated. When you solve it out, it's actually kind of easy. So that goes 3.36. We're over halfway there. All right, let's see how we go with the next ones.